A very happy morning to all, and welcome you all to study with me, and it's me Vidya here. So today we are going to deal with the new topic, resistance in series. So we are dealing with the grade 10 physics chapter, electricity and circuits, and this is the new topic. So for the previous topic you can refer to my channel, and I have also created a playlist on this chapter name, so you can go through it. So we are going to study about resistance in series. We already know what is resistance, right? So now we are going to find out what happens to the voltage and current when the resistance are connected in series. So what do you mean by series connection? So series connection, we will also called it as cascade connection. Okay. So series connection means, so we know this is how you will draw a resistor, right? So series means one resistor will be connected after the other. Okay, so one resistance will be connected after the other. So this is called as a series connection of resistor. So let this be resistance 1, this be resistance 2, and this be resistance 3. So this is called as series connection. Okay, so now we are going to find out what is the value of voltage, how does voltage and current varies when resistors are connected in series. Okay. Now let us consider a circuit. So I am connecting two different resistance. Okay, I am going to connect two resistance in a circuit. And I am connecting it to a voltage source. So any voltage V. Okay, I am connecting two resistance in series, and I am connecting the circuit to any voltage source V. So let the current flowing through the circuit be capital I, and let this be resistance R1 and this be resistance R2. Okay, so I am going to connect two resistance in series, and I am connected the resistance to a voltage source V. A current I passes through the circuit. Okay, now we can say that the current, okay, the current flowing in resistance R1 will be equal to the current flowing in resistance R2, which will be equal to the total current. Keep in mind, this is a very important point. In a series circuit, the current flowing through the resistance R1, so let this current be I1, okay, and the current flowing through resistance R2, let this current be I2. So I1 will be equal to I2, that is will be equal to the total current I. Okay, for example, in this circuit, if a current of 2 ampere is flowing, then the 2 ampere will be flowing in R1, and the same 2 ampere will be flowing in R2 also. So that means the total current will be same in both the resistance. I will be equal to I1, which will be also equal to I2. Okay, now let us find out how the voltage will be. Okay, so I'll redraw the circuit again. Let us find out how will be the voltage. Let us find out whether the voltage will be same or different. So this is the voltage source, this is the resistance R1, and this is resistance R2. A total current of I flows in the circuit. Okay, so let me consider the voltage across this resistance R1 is V1, and voltage across this resistance R2 is V2. Okay, and we know that voltage or potential difference is what? Difference in the potential between 2 points, right? So let me consider this as a point A, okay, this as a point B, and this as a point C. Okay, we know that potential difference is a difference in potential between 2 points, right? So this resistance is connected between these 2 points, point A and point B. Similarly, resistance 2 is connected between 2 points, point B and point C. The total voltage is connected between 2 points A and C. Okay, now let us find out what is this V1 value. What could be the V1 value? We know that potential difference is a difference in potential between 2 points, right? So what are the 2 points present in this R1? One is A and one is B. So can we write V1 will be equal to VA minus VB? Okay, it is a difference in potential between 2 points, VA minus VB. Similarly, how can we write V2? V2 is the resistance R2. It is connected between 2 points, VB minus VC. Difference in the potential. Now, what is the total voltage V? Total voltage is connected between the 2 points A and C. So, that is VA minus VC. Correct? That is VA minus VC. Now, think about this. Look into it. V1 is VA minus VB. V2 is VB minus VC. And V is VA minus VC. So, can we say that V will be equal to V1 will be equal to V2? Can we say that? No, because all these values are different. So, these are not equal. But in current, I is equal to I1 is equal to I2. But when we are speaking about the voltage, it is different. So, we can find out what will be the value of voltage. Okay. So, let us add V1 and V2. Okay. Let us add V1 and V2. Okay. So, when we add V1 and V2, what we will get? V1 value is VA minus VB. Okay. Plus, what is the value for V2? V2 is VB minus VC. Okay, so I am adding V1 and V2. V1 value is VA minus VB and V2 value is VB minus VC. So what happens? Minus VB plus VB cancels and I will get VA minus VC. Correct? I will get VA minus VC. So what is this VA minus VC? What is the value of VA minus VC? Yes, so total voltage is equal to VA minus VC, right? So we can write the total voltage V will be equal to the voltage across the resistor R1 plus the voltage across the resistance R2. Okay, the total voltage V will be equal to the V1 plus V2. That means the total voltage V will be equal to V1 plus V2. For example, if the total voltage is for example 5 volt, okay, then V1 can be either 3 or 2 volt. Similarly, V2 can also be either 3 or 2 volt. If we add these two, you have to get 5. Okay, is this clear? So this is very important. In a series circuit, the total voltage V will be equal to V1 plus V2. That means that the voltage is distributed. What does it mean? The voltage is distributed in a series circuit. This is very, very important. Okay. So now let us apply Ohm's law here in this equation. Okay. Let us apply Ohm's law. So V is equal to I into R. That is Ohm's law, right? By Ohm's law, we know that V is equal to I into R. So in the left hand side, we have V. So let us write I into R equal to V1. So instead of V1, let me write I1 into R1. Okay. And instead of V2, let me write I2 into R2. Right. So by Ohm's law, V is equal to I into R, and I am going to apply Ohm's law here. So V I am writing I into R. Instead of V1 I am writing I1 R1, and instead of V2 I am writing I2 R2. Now listen. This I1 and I2, we already told that I1 is equal to I2 is equal to I. Right? So in a series circuit, I is equal to I1 will be equal to I2. So can I write it as I into R1 plus I into R2, because I1 and I2 and I are same. Or I can write IR is equal to I into R1 plus R2. Correct? Taking I as a common term. What happens? This I and this I gets cancelled. So I will get R is equal to R1 plus R2. Or we can say that R equivalent. What is it? R equivalent in a series circuit. Or we will say that the equivalent resistance in a series circuit is equal to the adding all the resistance connected in the circuit, that is R1 plus R2. If there are 3 resistors, we will write R is equal to R1 plus R2 plus R3. If they are 4, R1 plus R2 plus R3 plus R4, etc. Okay, so this is a very important 3-mark derivation for your CBSE board exam. Okay, so V is equal to I into R. So instead of V, I am writing IR. Instead of V1, I am writing I1 R1, and instead of V2, I am writing I2 R2. So we know that I is equal to I1 is equal to I2 in a series circuit. So instead of I1 and I2, I am writing I. So taking I as a common term, we will get R equivalent is equal to R1 plus R2. Okay, so now we can summarize that in a series circuit, the current always remains constant. That is, the total current I will be equal to I1, which will be equal to I2, and the voltage gets distributed. That is, total voltage V will be equal to V1 plus V2. Okay, V will be equal to V1 plus V2. So this is very important. Okay, and one more thing. So I told you that we have two resistance. For example, I am connecting two resistance in series. Let this be R1 and let this be R2. Okay, and I am connecting it to a voltage source. Okay, I am connecting it to a voltage source. Okay, so for example, I am connecting a 6 volt supply to this resistance. Okay, and see if for example, this is a 2 ohm resistor and this is a 4 ohm resistor. I am connecting these two resistors 2 ohm and 4 ohm in series, and I am connecting it to a voltage 6 volt. Okay, so how to find out the voltage? So we know that V is equal to I into R, right? V is equal to I into R by Ohm's law. So the voltage and the resistance are directly proportional. Voltage and the resistance are directly proportional. Okay, so voltage and the resistance are directly proportional. That means if the voltage is higher, resistance will be higher. If voltage is lower, resistance will be lower. So I told you that this voltage, the total voltage will be split up into these two resistance. That is, V is equal to V1 plus V2. So how can we say which resistance will be having how much voltage? That is, see here, the total voltage is 6 volt. Okay. So 6 volt, it can be split up into these two resistance. Okay. So since this resistance 4 ohm is the highest resistance, highest voltage passes through 4 ohm. Is it clear? Since 6 volt voltage is given here, and since 4 ohm is the highest resistance when compared to these two, 4 ohm is the highest one. So highest voltage passes through 4 ohm and the lowest voltage passes through 2 ohm. For example, if a 6 volt, if it gets transferred as 4 volt or 2 volt, for example, I am saying, if it is transferred as 4 volt and 2 volt, this 4 volt will be passing through this 4 ohm resistor, because since this is the highest value, and 2 volt will be passing through the 2 ohm resistor since it is the lowest value, because both are directly proportional. Okay. So hope you might have understood this concept. So this is all for today. So we have dealt with what is the connection of resistance in series. So if we are connecting two resistance in series, the value of current remains constant. That means the total current will be equal to the current across resistor R1 and resistor R2, and the voltage gets distributed. That means total voltage will be equal to V1 plus V2. And the value of voltage across the resistor depends upon the value of resistor. That means if the value of resistance is higher, higher voltage passes through it. If the value of resistance is lower, lower voltage passes through it. Okay. So if the 6 volt is splitting up into 4 volt and 2 volt, for example, say, so here the 4 ohm is the highest value. So highest voltage will pass through highest resistor. Lowest voltage will pass through the lowest resistor. Okay. So hope you understand the topic, and if you have any doubts in this, please do let me know in the comment section. Subscribe to the channel, and we'll see you back soon, very soon, with another video. Thank you all.